Moving forward with chapter 2, I'm going to talk about ions and the periodic table. So we left off in the last video talking about this idea that we want to start talking about compounds. They're made up of bonds. And so we had ionic bonds and covalent bonds. And ionic bonds make up ionic compounds, and we know that these are composed of ions. We learned already that ions are charged atoms, right? So they're positive or negative, cations, anions. But ionic compounds are neutral. So an ionic compound is formed from the interaction between at least one cation and at least one anion. Overall, you have to make a neutral overall compound. So you need that positive and that negative. We don't have compounds we don't have just pure anions or just pure cations. They're always formed in pairs. So when we're talking about ions, one of the things we want to think about or want to know is there a tendency for atoms to form particular ions? And the answer is a hard yes. And a lot of those predictions are going to be based around the periodic table. We can't necessarily predict for everything, but we can make some predictions based off the periodic table. The first one is based around that first distinction we talked about, metals and nonmetals. One of the reasons why we talked about that is that metals form cations, nonmetals form anions. So when we're talking about individual atoms, if that atom is a metal, if it's on the left of that metal line, if it forms an ion, it will be a cation. And anything that forms cations has to be a metal. Nonmetals form anions. So on the right side of that line, we're expecting to find anions. So we can use the periodic table and that arrangement to make predictions. That's why it's really helpful to have it as a tool. We can start to predict. This is chemistry. Where an atom is on the periodic table is going to start to predict the chemistry that it does. So we have generic metal, nonmetal. We can also make predictions about what are called fixed charge ions. Fixed means always the same. So for a handful of elements, when those atoms form ions, they always have the same charge. Now, metals, nonmetals, always positive, negative, but here we're talking about the specific value of how positive and how negative. So we can look at some different regions of the periodic table and make predictions. The first region is the noble gases. The noble gases are stable as atoms. They do not form ions or bonds, right? One of the whole points of noble was that they were non-reactive. Since they are non-reactive, they don't do chemistry. Forming an ion is doing chemistry. Noble gases do not form ions. So they just don't do that. They're going to always just stay neutral. If we then look at our nonmetals, right, that far side, we can see that they are forming anions. Okay, so the nonmetals that aren't noble gases, when they form ions, will always be anions. They will always go negative. And how negative is determined by the number of columns away from the noble gases. So again, it's based off column. Columns have similar chemical properties. So we can see that the halogens are one column away from the noble gases. That's why they're all -1. When we go to the oxygen column, we're now 2 columns away from the noble gases, so it's -2, -3, -4. You will note that when you get towards the bottom of the column, you start to hit the metals, they're no longer consistently forming those. So it's nonmetals near the tops of the columns. You can also start to see why halogens and noble gases have their own name, because all of the atoms in those columns are consistent. They all have consistent, either in the noble gases, no ions, and in the halogens, -1 for the charge. If we look to the other side, the alkali metals and the alkaline earth metals, because they are metals, they form cations. All metals always form cations, but the first 2 columns are fixed charge. Okay? The alkali metals, because they're column 1, go +1. The alkaline earth metals, because they're column 2, go +2. So the size of how positive they go is based on the number of the column that they are. So the edges of the periodic table, kind of the far right and the far left, we can be consistent and we can predict the charge based off the column that that element is in. Unfortunately, there's a handful of other metals that are always cations. In this case, we can just know that they're metals, so they will be cations. But silver is always +1, zinc is always +2, and aluminum is always +3. When it comes to the periodic table, we can kind of explain and justify it based on some stuff we'll learn towards the end of the semester. But for now, this will be something you just want to memorize. You want to memorize that silver is always +1, zinc is always +2, and aluminum is always +3. So these are fixed charge metals. This is going to be what their charge always is. You can kind of see that they're in a zigzag right there. If you just memorize aluminum 3 and then kind of count down, you'll see zinc. You can see that you're going, you go do do. So that kind of stepped pattern, but those are in fact fixed charge metals. Got to just learn those. You can't really use the periodic table, but you don't need to memorize rubidium, because rubidium is you just need to memorize the alkali metals, R+1, and be able to find Rb on the periodic table. So with that in mind, we want to be able to predict ions for our elements. And obviously, we didn't talk about a lot of the periodic table because you can't. But in this case, we want to be able to predict for those elements that are near the edges of the table. So what ion is Br likely to form? If we want to predict ionic charge, the first thing is always find it on the periodic table. Right, there's that handful, aluminum, zinc, silver, you just kind of learn those. But in this case, bromine, we can find it, Br bromine, it's right here. Okay, so one of the things we can see, it's a nonmetal. So right away, we would expect it to become an anion. It's going to go negative. Okay, so we know it's going to go negative. So the question is, how negative? And we can figure out how negative based on the column it's in. Bromine is in group 7A, so we can see that it is 1 away from being a noble gas. You can literally count 1, right? And so because you're counting 1 away, we know it's going to be negative, so it's -1. Everything in group 7A goes -1. Everything above bromine, everything below bromine. So they would all be -1. Once you know what column it's in, you're done for figuring out the ionic charge. Okay, so let's do Ca. Okay, Ca is right here. Okay, so once I find Ca, if I want to know what ion it's in, I can see that it's a metal, and this periodic table has a blue background. So because it's a metal, that means it's going to be a cation. I know the charge will at least be positive, so we could get that far. Partial credit's great, so if you get a positive on there, you're good to go. That's something. So then the question is, how positive? And in this case, again, it's counting. And we can see that we're in group 2A. It's all about what group is that ion in. So because calcium's in group 2, and in this case, because it's a metal, on that side, we're just counting 1, 2. Calcium has a charge of +2. Once you know what group it's in, you can figure out that it will be +2. When you find out it's a metal, that tells you the plus part, and the column it's in tells you it's the 2 part. And so everything in that column is going +2, right? And one of the ways you can think about counting that is you're still counting to the noble gases, you're just counting backwards. So you're at 19, you're at 20, you get to 19 as a noble gas. And then when you count backwards, it kind of wraps around the periodic table and you get to the 18. You're still counting to the noble gases. That counting is just a little more convoluted because you're counting backwards. So 19, 18, that's 2 steps to get back to the noble gases. Because remember, they don't form ions. So when other things form ions, it's to become a noble gas, like a noble gas. So those were the fixed charge elements. You will note we didn't talk about a lot of atoms. That's because they are what's called variable charge. So fixed charge means they're always the same. Most elements are not always the same. If those atoms form ions, they can have different possibilities. So one is hydrogen. Even though it's in group 1A, you'll note we don't lump it in with the alkali metals, and that's because it can form positive or negative ions. It's actually the only atom that can go cation and anion. But it can do both, H plus or H minus. It's because it only, if you think hydrogen is atomic number 1, so neutrally it only has 1 electron. So losing that electron or gaining an extra electron are both pretty small changes. So the rest of the periodic table is mostly the metals. You have the main group metals and you have the transition metals. So we can make certain, we know certain things about them. One, we know that they are going to form cations. So we know for a fact they are certainly going to form cations. They will never form anions, but you cannot predict what type of cation. Right? Iron forms iron 2 plus or iron 3 plus. Both of those are possibilities, and you cannot predict it. So I can't give you a participation question of asking what kind of charge, what's the ion that Fe is likely to form, because no one can answer that. In different compounds, in different situations, iron will form different ions, either +2 or +3, but there's no way you can know. So you can't predict it, I can't predict it. I would never ask you, what ion is iron going to form? Now, you can predict that it's going to form a cation. So, because it's a metal, and we want to be able to do that, but that's going to be the extent of it. The book talks about likely charges of variable metals. I do not expect you to know that. I do not expect you to know iron really only does go +2 or +3. That's the most likely things that you find it in. And you can know those things, but that's just pure memorization. It isn't really super important. So you do not need to learn those likely charges. You don't need to know what copper tends to form or rhodium tends to form. You just need to know that they can form different charges, and there's no way to predict what it is because there's 2 possibilities.